Hello everyone, welcome once again to my channel. Now in this section we have a question on random continuous variable, and then the question says that let y be a random variable with PDF where f of y is given by the piecewise function 3y squared divided by 64 and then multiplied by 4y 4 minus y, and then we are given the condition from 0 to 4 and then 0 elsewhere. Now the question says that we should find the expected value, which is the mean, the variance, and also the standard deviation of y. And then also the sub question says that let y, if s equal to 300y plus 5, we should find the expectancy of s, and then also the variance of s, and then we should also find the probability that s is greater than 750. So let's look at how we can solve this question. Alright, so the expectancy here, which is mu in this case, is equal to the square root of x multiplied by f of x dx a to b. So in this case we have it from the upper limit for lower limit 0, and then we have x multiplied by, so we are multiplying x by we have the piecewise function to be this, so we have 3y squared divided by 64 here, right, multiplied by 4y, 4 minus y, and then dy in this case. So since we are using y, so let's use y in every case, right, e of y, expectancy of, so we are looking for the expected value of y. Okay, so from here we can simplify that, so let's simplify that quickly, and then from here we have 3y squared over 64 multiplied by 4. 4 goes into 64 16 times, so multiplied by this y again, so we have 3y cubed divided by 16, and then minus y multiplies that, which is 3y cubed over 64 multiplied by y squared. So we have 3y, so we have cube and then to the 4th power being divided by 64, and then dy in this case. Good. Now from here we go ahead and then we integrate from here. So integrating that, we have we add plus 1 to the exponent, so it's just going to be 3y to the power 4, then divided by 16 multiplied by 4, then minus 3y to the power, we add 1 to the exponent, and then we divide by that, so 64 then multiplied by the exponent that we add, and then remember it's from 4 and then 0 here. So from here, when we further simplify this, we are just going to get this to be 3 to the power 3y to the power 4 divided by 64 here, and then minus 3y to the power 5 here, and then 64 multiplied by 5 is just 320, and then it's from 4 and then 0 for each of the cases. So the expected value is that. So from here we just substitute 4 into it, 4 to the power 4 over 64 here, and then minus 3 4 here, power 5 320, we have that, and then minus the 0 part. When we substitute 0 into each and every part, it goes away, right? So expectancy, and then from here we have that the mu here. So from here the mu here is just going to be 12 divided by 5 when you compute the whole of that, which is just equal to 2.4, and that will be the mu in this case. And the next question says we should find the variance. So the variance of y in this case is just going to be the square root of in this case y squared, and then 4 here, 0 here, and then the piecewise function is giving us 3y squared here being divided by 64, and then 4 minus y here, and then dy in this case. Good. Now so we simplified this again, So we have the integral from the upper limit 4 to the lower limit 0, and then when we multiply through, we are just going to get 3y to the power 4 divided by 16 here, and then minus y squared multiplied by that, and then it multiplied this also, so we have y to the power 5 divided by 64, and then we have the y here. So from here, what we do is to just integrate from here, right? So integrating from here, we add plus 1 to the exponent, and then it's just going to be y to the power 5, and then we divide by that. So 16 multiplied by 5 here is just going to be 80, minus, we just have y to the power 6 here because we had plus 1, then divide by the 6, so 6 here, and then when we divide by 6, 3 goes in itself, 1 goes here 2, and then we have 64 multiplied by 2, which is just going to be 128 in this case, and then we have 4 here and then 0 here. So just as we did for the first part, but remember again, we have mu squared, everything here mu squared, and then mu squared for the variance. So from here we just substitute 4 into it, so 3 and then 4 to the power, that's 80 here, minus 3 and then 4 to the power 6 over 128 here. And then remember, when we substitute 0 into it, everything goes to 0, and then we are left with the mu squared here, right? Then from here, when we have the variance of y, which is the same as that. So when we compute the whole of that, we should get something like 32 here divided by 5 minus mu squared, right? And then from here we have 32 over 5 here minus, and then mu we add to be 2.4, and then we square that, and then when we compute this, we should get our variance to be equal to 0.64. So from here we can conclude that therefore our variance here is just equal to 0.64. And then the next question says we should find that C, still part of A, the standard deviation is just equal to the square root of the variance, right? So it's just something like the square root of the variance, which is x squared p of x here, minus the mu squared, which is just what we add here. So it's just something like this, and then we just substitute that into it, and then we have square root of 0.64 to be equal to 0.8 here. So that will be the standard deviation for the piecewise function. Now the question says that we should let s be equal to that. So if s equal to that, we should find the expected value and then also the variance again. So let's look at how we can do that. So now when we let s be equal to 300y plus 5, which means that our expected value of x in this case is just going to be the expected value, and then what is x? So x is that, so we just substitute that into that. So we have something like this, and then this is just properties of expectation or solving mean. So I said solving something like this, the emphasis is on the variable we are looking at, the function depends on, which is y. So this is a constant, it comes out as 300, and then we have the expectancy of y here plus 5 here, plus 5 here. So this is just going to be equal to 300, and then what is the expectancy of y? The expectancy of y was the first question we did, so that is the value we add that one to be 2.4, right? So with the 2.4 we substitute that into it, and then plus 5, and then when you compute the whole of that, you see have 770 to be the expectancy of y. Now the next question says what is the variance of y, of x, remember it's x. Okay, so in this case we have so the variance of x, which is just what we are given over here, 300y plus 5 here, right? And then this is just going to be, so in the case of variance, it is a bit different from expectancy. The property says that if it's a constant, it comes out, then the emphasis will be based on the variable the function is dependent upon. So from here, what we do is that 300 is also a constant, so it comes as 300, but this time we square that one, we square the constant value, and then we have the variance of y, and then what is left is just a constant, so it comes out as just 5. And then 300 squared is just so we have 300 squared, let's leave it this way, and then the variance of y, we just did the variance of y, which we had to be 0.64. So substitute that into it, then when we compute the whole of that, we should get 57600. Yeah, so it's supposed to be 5 here, so 605, and that will be the variance of x. Okay, now from here, the next question says that we should find p, the probability that the x rather is greater than 750. The x is greater than 750. This is supposed to be y. Okay, so the question says that we should find the probability that s is greater than 750. So now remember, the function is with respect to y, but then you have to find the probability that s is greater than 750. So what we are going to do here is that we know what s is. We are given s to be the question says that we should let s equal to 300y plus 5. So we have 300y plus 5 here, which is greater than 750 here. Now what do? We multiply times from here, so we have 300y on this side, then greater than 750 minus 5, so this moves to the other side, and then we have this. So from here we have 300y greater than so when we do that, when we subtract that, then we should get 740 here. So from here we have y greater than, so what we do is to divide both sides by 300, and then we have 740 divided by 300 here. So p here is just going to be y greater than that. So let's do some changes here. So let's do this place 50, so 300y plus 50. So in this case, this part is going to change, so 50 50 50 50, and then we are going to get a 770. That is why I wrote 770. It's supposed to be 50, and then this place is supposed to be 50 50 50. So this changes to 57650. So that will be the variance of x in this case. So now if it is 50, then which means that this place is 50, this place is 50, and then it becomes 700 here. So you know we are going to get 7 over 3, because it will cancel out in this case. So that will be the now what we have done is that we have been able to write everything with the parameter y, because first we are given with the parameter x here. Now we have been able to write everything with the parameter y, and then remember the piecewise function is with respect to y, which is giving us 3y squared over 64 here, and then we have 4 minus y here, and then we are given this condition that is from the question. Now the question says we should find the probability that y is greater than 7 over 3 now. So that is what we are going to do now. Remember, it is 7 over 3, and 7 over 3, if you look at 7 over 3, it is less than 4, so it is in between that. So now what is going to happen is that our integral is just going to be from the highest value over here, because what now the probability is that y is greater than 7/3. So which means that this becomes our lower limit, and therefore from the piecewise function, the general range that we are given over here, this becomes the upper limit here. So we have the upper limit of 4 and then a lower limit of 7/3 in this case for the probability that y is greater than 7/3. Now, so from here we just compute that. So we just have 3y squared over 4 goes into 7 goes here 16, and then we have y cube divided by 64, and then the y. Yeah, so now this is what we are. So this is the probability that y is greater than 7/3, and that's what we are solving now. So from here we go ahead and then integrate from here. So we have 3y, we add +1 to the exponent, and then so it becomes 3 here, and then it becomes 16 over, then we divide by the exponent, which is 3 minus 3 to the power, we add +1, it becomes 4, and then we divide by 64 multiplied by 4, and then remember 4 and then 7/3 here. 3 gets rid of 3, and then from here we have y cube over 16 here, then we have minus y cube over 16 minus 3 over 64 multiplied by 4 is just 256 here, 256, and then y to the power 4, and then we have 4 here, and then 7/3 here. Good. Now from here we can then go ahead and then simplify that. So we just put the 4 here, so we have 4 cube over 16 minus 3 4 to the power 4 over 256 here, and then minus, just substituting so the next one is just substituting 7/3 into it, 3 here over 16 minus 7/3 here to the power, remember it's multiplied by 3, and then to the power 4 divided by 256, and then we have that. So this is still the probability that y is greater than 7/3 that we are still doing. So from here the whole of that, this just gives us the whole of that, this gives us 1 minus the whole of that also gives us 43/768 here, and then when we compute the whole of that, we should get 0.55339 as the probability that y is greater than 7/3. So the probability that y is greater than 7/3, which was formerly the question was the probability that x is greater than 750. Remember, we just substitute the s into it, then everything now amounted to y greater than 7/3, which is just equal to 0.55339 as the final answer. So thank you very much for joining in this section, and then I'll see you in the next section, which will be the last video on continuous variable, and then from there we can then go ahead and then talk about central limit. So I'll see you in the next video.